All right, welcome back, and let's talk about solving a system of equations using the substitution method. So today we're going to be using this problem as an example, and it's going to be 3x plus 3y equals 3, and 5x plus y equals 13. Now, this particular type of system of equations is going to be extremely helpful for using with the substitution method, because since we have a variable with the coefficient of 1, it makes it easier to solve for that particular variable. So whenever you're doing these problems, what you want to do is check all of your variables and see if you can find one of them with a coefficient of 1 or -1. So of course we look here, this is a 3, this is a 3, this is a 5. And remember, when we're looking for the coefficient of 1 or -1, it is going to be invisible. It's going to be that variable standing by itself. And depending on if that sign in front of the variable is positive or negative, it will tell you what your sign is going to be on that one. So this particular problem has a positive 1. So now, what we're going to do to make this a little bit easier is we're going to actually circle this variable. So again, we're going to circle the variable. And I like to draw this little line to separate my two sides of my equation. Now, what I'm going to do here is I'm going to try to get y by itself. So when I'm doing that, I look over here, I see what else is left on this side with y. I see this 5x. I know it's addition, so I'm going to subtract it from both sides. So that's going to give me this 5x minus 5x, which will cancel out. And then over here, and that will leave y. And then over here on the right side, I have -5x plus 13. So now this gives me this new expression, which is exactly what I wanted, because this expression here is equal to y. So now I can plug this expression back in for y in my first equation. So let me go ahead and rewrite my first equation as 3x plus 3 times -5x plus 13 equals 3. So now, as you can see, I rewrote that equation. I plugged in this expression for y, and now I'm going to distribute it. So I have 3x minus 15x plus 39 equals 3. Now I combine like terms. I get -12x plus 39 equals -3. Or sorry, equals 3. So now that I have this here, I can solve this equation for x. So when I solve it, I have -12x plus 39 equals 3. Remember, I'm solving for x. X is my variable. So to get x by itself, I'm going to get rid of this 39 first, because remember we use order of operations backwards when we're solving for a variable. So on the right side, that's going to give me negative 36. And on the left side, that gives me negative 12x. So now I divide by negative 12 on both sides, and that gives me x equals 3. So now I've completed the first part of this problem. I found a value for x, and now all I need to do is plug this value of x back into one of these equations to solve for y. So I'm going to use this equation right here. So when I plug it back in, I get y equals negative 5 times 3 plus 13. I distribute negative 15 plus 13 equals y. Y equals negative 2. So now I have both of my variables, and in order for me to say that this problem is complete, I must put them in an ordered pair, and that ordered pair would be 3, negative 2. Now I am complete, and I have found the solution to this system.